Hey everyone, and welcome to this explainer. So in the next 10 minutes, you're not just going to learn what machine learning actually is, you're going to discover the 3 core ways these algorithms learn, how your favorite apps literally predict what you want before you even know it yourself, and how to spot machine learning hidden right there in your daily life. Let's dive right in.
Right off the bat, here is the absolute core question we are going to unravel today. How exactly does a computer learn to do something incredibly complex without a human sitting there giving it explicit step-by-step instructions? I mean, for decades, computers were basically just really fast, obedient calculators. But today, they are actually making complex decisions. So how on earth did we get here? To answer that, here's our roadmap. We're going to cover the core concept, the 3 types of learning, how the machine learning pipeline works, the difference between AI, ML, and deep learning, and then we'll wrap it all up.
Okay, starting with part 1, the core concept.
To really get this, we have to look at the massive paradigm shift from traditional computer programming. In the classic way of doing things, a software developer writes explicit rules. You feed the computer input data, apply those rigid rules, and you get your output. But machine learning? It completely flips this formula on its head. Instead of giving it rules, you feed the computer massive amounts of data alongside the desired outputs, and the algorithm itself figures out the rules. So traditional programming runs on instructions, while machine learning runs purely on examples.
Now, you might be wondering, why do we even need this new approach? Well, early AI systems kind of worked like giant flowcharts. If you wanted a computer to identify a photo of an apple, you literally had to code every single rule. It has to be round, it has to be red, it needs a little stem. But real-world data is super messy. What if the apple is green? Or what if it's half-eaten or in a really dark room? Writing out rules for every single possible scenario is just impossible. Machine learning algorithms bypass all that. They just need enough examples to adapt on their own. Which brings us to part 2, 3 types of learning. Let's look at how these algorithms actually pull this off. Algorithms generally use one of 3 main methods to learn: supervised learning, unsupervised learning, and reinforcement learning. And each of these approaches relies on a totally different kind of signal or feedback to help the algorithm extract rules from the data. Supervised learning is for sure the most common type. It's essentially learning with a teacher. You can think of it a lot like studying with a huge deck of flashcards where the answers are written right on the back. For example, you hand the computer 10,000 images of houses, along with their actual sale prices. The model studies that labeled data and learns the hidden mathematical relationship between, say, the house's square footage, its location, and the final price tag. Once it's fully trained, you can show it a brand new house it's never seen before, and it'll accurately predict the price.
But wait, what if you don't actually have the answers? That is exactly where unsupervised learning comes in. In this case, the data has no labels at all, no correct outcomes are provided to the system. The model's entire job is purely discovery. It has to organize the messy data into meaningful groups based entirely on hidden similarities. A really great real-world example of this is an e-commerce platform segmenting its customers. The algorithm groups buyers with similar habits together without ever being explicitly told what traits to look for. It's basically organizing pure chaos into structured insights.
And then we have the third method, reinforcement learning. Honestly, the best way to think about this is like training a dog with treats. You have an AI agent placed into a specific environment. The agent takes different actions, and depending on whether those actions are good or bad, it receives either a reward or a penalty. Through millions and millions of cycles of pure trial and error, the agent learns a strategy to maximize its rewards. This exact method is how self-driving cars learn to stay in their lanes, and it's how algorithms have completely mastered incredibly complex games like chess and Go. Moving on to part 3, the machine learning pipeline. Because, this isn't just magic, it's an engineering process.
Pretty much every machine learning system follows a core 4-step pipeline. Step 1 is collecting and cleaning the data. Fun fact, this actually takes up roughly 60 to 80% of an AI project's total time, because let's be real, bad data in means bad predictions out. Step 2 is training the model on that prep data. Step 3 is testing and evaluating the model using entirely unseen data. And finally, Step 4 is deploying that model out into the real world and continuously iterating on it as fresh data rolls in. Let's zoom in on that training step for just a second, because it's absolutely crucial. Training is essentially just a massive, repetitive cycle of predict, measure, and adjust. The system gets the prepared data and makes a wild guess. It then compares its guess to the actual correct answer, calculates exactly how far off it was, and then automatically tweaks thousands, or sometimes even billions, of internal mathematical knobs which are known as weights and biases. Think of it like learning to throw darts. Every single throw gives you feedback, and you subtly adjust your aim based on where the dart landed. Through a mathematical process called backpropagation, the model incrementally gets better and better. But here's the thing. The ultimate goal isn't just to perfectly memorize the training data. We need the model to actually generalize. An optimal system takes all of its rigorous mathematical training and successfully applies it to messy, unexpected, unseen inputs in the real world. Honestly, that's the true test of machine intelligence.
Okay, let's look at part 4, AI, ML, and deep learning. We really need to clear up these terms.
People use these words interchangeably all the time, but they aren't the same. Think of them like nested Russian dolls. Artificial intelligence is the biggest, outermost doll. That's the broad umbrella concept of programming computers to mimic human intellect. Right inside that is machine learning, which is the specific subset we've been talking about, where machines learn automatically from data. And nested right inside of machine learning is deep learning, which is a highly specialized core that relies on incredibly complex, multi-layered artificial neural networks. Under the hood, deep learning relies on hidden layers of artificial neurons, which are actually mathematically inspired by the biological neurons in our own human brains. Data passes forward through all these interconnected layers, and because of these deep, complex structures, the network can extract incredibly intricate, high-level features from data, way beyond what simpler machine learning models could ever achieve. Because of this intense architecture, deep learning is the powerhouse behind the most advanced tools we use today. It's the engine for natural language processing, allowing chatbots to have completely fluent conversations with you. It drives advanced computer vision, giving software the almost magical ability to recognize faces or spot medical anomalies in X-rays. And of course, it completely powers generative AI, creating startlingly realistic text and images just by predicting the next logical word or pixel based on its massive training sets.
All right, part 5, conclusion and wrap up. Let's bring this all together. If you take away just one single thing from this explainer today, let it be this. Machine learning is not magic. It's simply statistical pattern recognition scaled up to an unimaginable degree by raw computing power and massive mountains of data. Instead of human beings painstakingly trying to write a rule for every single possible situation in the universe, we've essentially built systems that learn the rules on their own, straight from examples. And the crazy reality is, you are already interacting with these trained algorithms every single day. They are constantly working silently behind the scenes to filter the spam out of your inbox, analyze your listening habits to curate your next perfect streaming playlist, detect strange anomalies in your credit card purchases to stop fraud in real time, power the voice assistants sitting right there on your kitchen counter, and even generate the predictive models that forecast tomorrow's weather. As we generate more and more data, and as computing power continues to absolutely skyrocket, these models are only going to become deeper and far more capable. So, it really makes you wonder, what hidden patterns will machine learning uncover in our world next? Think about it. Well, if you found this 10-minute breakdown helpful, make sure to hit that like button, subscribe for more simple tech explainers, and drop a comment below letting me know what complex tech topic we should tackle next. Thanks so much for learning with me today.